All right, welcome back everyone. Today we're going to be looking at ellipses. We'll be doing part two tomorrow. Part one, we're going to be focusing mainly on graphing an ellipse. So an ellipse is our second conic section. We looked at circles last week. An ellipse is essentially an oval, as most of us would probably refer to it, but oval's not really a mathematical term, so we'll be calling them ellipses. So they kind of define an ellipse. An ellipse is a set of points such that the sum of the distances from any point on the ellipse, the two fixed points remain constant. These fixed points are called it's the plural of focus. I usually say foci, but it's Foci. So it's the foci of the ellipse. It's the plural of focus. So I kind of say it like focus, but I could be completely wrong. But one thing about these distances between the focus points is that it will remain constant no matter where you are on the ellipse. So if you look at this diagram on the right, like you have your two focus points, and we'll talk about kind of how to find those, but you would see that the distance will stay the same. So like, for example, if I drew another point here, the distance to these two focus points would be the same as the distances for this original point. Okay, so it's not that, like, I mean, at least for what we're doing, it's not that important, but maybe if you do more with conic sections, you'll talk a lot more about kind of the importance of your focus points. But it's just kind of by definition what makes an ellipse an ellipse. Some more parts we'll be looking at. The major axis is the longer axis of symmetry, and the minor axis is the shorter axis of symmetry. So like if you think of an oval, one way around it, like one diameter, it's not really a diameter because it's not a circle, is going to be longer than one way. And we'll see, we can either have a horizontal ellipse or a vertical ellipse based on which, if it's our vertical axis that's longer, or if it's our minor axis that's longer. The center is the point at which the major and minor axis intersects, or it's just the middle of your ellipse. So your center hopefully won't be too confusing. The vertices are the endpoints of your major axis. Oops. And your co-vertices are the endpoints of your minor axis. And these notes, just so you know, I posted the key as well as a blank copy under the classwork tab. So if you can't read my chicken scratch or you want to clarify something, just FYI, they are posted there. So as you can see, there's two types of ellipses. A horizontal ellipse where it's longer wide ways or horizontally, and you have a vertical ellipse where it's longer vertically than it is wide. That helps. I'm going to add some of these vocabulary words we just talked about into this picture. So this long line here would be the major axis, like that goes horizontally, like the diameter, but we don't call it a diameter because it's a ellipse, not a circle. So it's truly not a diameter. This line going up and down is our minor axis because it's shorter. We'll see it's kind of reversed in the next example. Obviously, this middle point is your center. Oops. So since this is my major axis going across left and right, these 2 points, here, maybe I'll color code this. I'll do it in red. These 2 red points, those would be called your vertexes because they're the ends of your major axis. These blue points, since they're the ends of the minor axis, these are called our co-vertices. So these blue points would be our co-vertices. These yellow points, and we'll talk about how to find these. These are called, these would be your focus points, basically, like no matter where you are on the outside of your ellipse, it would be equal distance to those 2 points. I'm not going to lie to you, at least in this class, we're not going to do a ton with focus points, but especially if you get into some upper level mathematics, you probably will do more with them. I personally never really did that in my trajectory. Kind of depends what classes you end up taking, what your teachers focus on, but these yellow points are the focus points. And I know my drawing's kind of messy. It's kind of hard on my iPad. If you do look at the notes key, it's a little more clear. So this kind of holds true. The only difference between the horizontal and the um, vertical ellipse is this line here. Now that's my major axis because it's the longer one. So my vertical line's the major axis, and then this one going like horizontally is my minor axis. And you would see like your center, your vertices and your co-vertices, you could find the same way. Like these green points would be my vertices because they're on my major axis, while these red points would be my co-vertices because they're on my minor axis. And just some more kind of facts. The vertices are always, we say it's plus or minus a units from the center. We'll kind of talk about what that means. We're going to have formulas, but to find your vertices, it's plus or minus a from the center. Your co-vertices are plus or minus b from the center. We'll see how this relates to the formula that's coming up. The length of your major axis is 2a, and the length of your minor axis is 2b. The focus points, or the foci, are plus or minus c away from our center. And a formula to find your c is that it's c squared equals a squared minus b squared. And one note, it is not Pythagorean theorem. It looks like it, but it's minus b squared, not plus b squared. So just be careful. It's not, we're not actually doing Pythagorean theorem, even though it looks very similar. So our equations, and these are kind of what we'll be using as we're graphing. If your center is at 0, 0, which is kind of a nice case, your formula is going to be this: x squared over a squared plus y squared over b squared equals 1. So we'll see that for an ellipse, it's always going to be equal to 1. And this left box is, this would be for a horizontal ellipse. This right box, this is what the equation would look like if it was a horizontal ellipse. You would see that your B is always smaller than your A. So maybe I'll write that here. One fact is that your A is always greater than B, or B is always less than A. But basically, if you, we'll kind of see how this works, is that if your x turns over a bigger number, that means that you have a horizontal ellipse. If your bigger number is under your y term, that means you have a vertical ellipse. But we'll kind of see that when we get into some examples. So I'm just going to write a note here. So this would be a horizontal ellipse, and this box here would be a vertical ellipse, just based on where the bigger denominator goes. So if your bigger denominator is under your x part, you'll see it's horizontal. If your bigger number is under your y part, well, you're going to see you have a vertical ellipse when you're kind of graphing. But sometimes you're going to have, well, most of the problems we'll actually probably get into, you're going to see that your center's not always at 0, 0. It might be kind of off center on your graph. So it kind of takes, it's similar to the circle formula. Where you just look at, you pull out your h and k from the top, and that's just going to give you your center. And it's still going to always be set equal to 1. And once again, on the left box is horizontal, the right box is our vertical. So we're looking at a lot of stuff. So I think probably one of the easiest kind of ways to kind of start putting some of this stuff together is to start looking at some problems. So we are going to be graphing some ellipses. One thing I'm going to do is I'm going to try, at least for this first one, I'm going to keep so you can see the formulas above in standard form. Um, so the first thing you want to do when you're graphing an ellipse, what I would do is figure out what your A and your B term are. So one note, just remember, your A is always greater than your B. So the first thing I look at when I have this equation is it's x squared over 4 plus y squared over 36. I look at which number is bigger on the bottom. So 36 is the bigger one, so that's my A. So right now we know A squared is 36 based on that formula above. Let me move this out of the way. And I know that my B squared would be the smaller one. Your B is always the smaller denominator. If you remember, above in the notes, we said that, because we're going to be trying to find our vertices and co-vertices to help us graph this, is it says that our vertices are plus or minus A units away, our co-vertices are plus or minus B. So one thing to notice is we're not talking about it in terms of A squared or B squared. So we want to take the square root of these. So my A is really 6, and my B is really 2. So my center, you always look at the top. Since x squared and y squared are by itself, my center is just going to be 0, 0. My vertices, we're going to use my A value. So first off, another thing we might want to look at is this going to be a horizontal or a vertical ellipse? But since my y value has the bigger number underneath it, that means this is going to be a vertical ellipse. Like, for example, if you look at number 2, since x squared has the bigger number underneath, that would actually be a horizontal ellipse. It's going to be like a wider one instead of a taller one. So to find my vertices, well, since I know this is a vertical ellipse, I know it's going to go up bigger. So I'm going to, basically, you just take your center and you add your A value to the Y values because it's vertical. So my vertices would be 0, 6, you add it and you subtract it. So you could either do 0 plus or minus 6 or just write the two separate points. But you basically add and subtract your A value from the vertical, because it's vertical in this case. If it was horizontal, you would add or subtract it from the X values. We'll see in the next problem. To get our co-vertices, we add or subtract our B value from the X value. So it would be 2, 0, negative 2, 0. And that's pretty much all we need to graph. I'm going to talk about the focus points, but we have enough right now to graph our ellipse. So we would put a point, and this is going to be a little sloppy on our iPad, but it would be 0, 0. Our vertices are 6 above. Come on. 6 below the center. And then we do our co-vertices, it'd be 2 to the right and 2 to the left. And if you draw it in, that's our ellipse. To get the focus points, you use that formula c squared equals a squared minus b squared. So in this problem, c squared would equal 36 minus 4. Or really, c squared would be 32. And if you take the square root of 32, c would be approximately 5.66. And your focus points, you always add it, like if you have a vertical, like one thing about your focus points, they're always going to be on your major axis. So if your vertices, oh no, 1 sec, I'm sorry. What the heck? Okay. All right, my bad. Here, let me get back to where we were. Okay, there we are. What I was saying though, if you look at your vertices, if there's 0, comma, whatever, that's what your focus points are going to be like. Your focus points are always going to look like your vertices, like in terms of your y value. So our focus points would be 0, 5.60, negative 5.66. So if you graph them, I mean, we're not going to be super accurate, but you would see they're always on your major axis near your vertices. They're just a little bit shorter usually. Okay, let's look at another example. So we're just going to keep doing a bunch of examples, but once you get it down, you'll see these problems are all pretty similar how you want to approach them. Okay. Okay, this is being weird. All right, so looking at number 2, like I said, the first thing you probably want to think about is, well, one, are you going to have a horizontal or a vertical ellipse? Because that's going to kind of help you think about what your vertices and co-vertices should look like. So since the x value, x squared is over 64, y squared is over 25, well, the x is over the bigger number. So that means your x value is the larger one. So that would be a horizontal ellipse. So that means, and remember, your a is always bigger than your b. So your a squared is the 64. Your b squared is the 25. So we don't usually want to work with these squared terms unless we're finding our c, we'll see. But so our a would be 8. Our b would be 5. And once again, if you look at the top, x squared by itself, y squared by itself. So our center, once again, is just 0, 0. So since we're looking at a horizontal ellipse, we're going to add our a value to the x values this time. So our vertices would be 8, 0, negative 8, 0. Our co-vertices, we're going to, since it's a horizontal, the smaller value, we're going to take our b, which is 5, and we're going to add or subtract that from the y values of this. So it would be at 0, 0, 5, 0, negative 5. So now we got enough to graph. We can do the focus points last. And I might stop doing these focus points because, to be honest, with what we're doing in this class, we don't really do a lot with them. I'm mostly interested in just getting our vertices and co-vertices in your center, because that's really what you need to get a graph. But I'll find the focus points for these notes, but I might cut this out of your homework assignment later this week. We'll see. But to graph this, our center's at 0, 0. Our vertices are at 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. And 1 to the left, negative 8, 0. As long as I counted correctly. Your co-vertices are up 5, down 5. So then do your best to draw an ellipse around it. That was kind of sloppy, but oh well, it worked out. To find your focus points, remember you just use that formula, c squared equals a squared minus b squared. So in this problem, it would be 64 minus 25, and you get 39. And we want to just find c, so you square root it. So the square root of 39 is approximately 6.24. And remember, since our vertices, like since this is horizontal, your focus points are always going to be on your major axis. So it's going to be, it's going to be added to the x values. iPad sometimes annoying. Okay, okay, there it goes. Okay, so we're gonna add 6.24 to the x value of our center, so it would be 6.240, negative 6.240. So it would look something like this. Like I said, I'm not really, but you see it's on your major axis, just a little bit shorter than your vertice points. All right, let's look at some examples, because these first two, our center has been 0, 0. Let's look at how these kind of change when your center is not at 0, 0. We'll see it's kind of a little bit, you got to be a little more careful when you're finding your vertices and co-vertices. So this one, the first thing I want to look at is it going to be horizontal or vertical? Well, the x part's over 49, the y part's over 9. So since the x part's over the bigger number, this is going to be horizontal. So our a squared value is 49. Our b squared value is 9. So we want to square root those. So our a would be 7. Our b would be 3. Since this is horizontal, remember, we're going to be adding the a value to our x value, add it and subtract it. We're going to take our b value then and add it or subtract it to the y value, because that would be our minor arc. So our center, though, if you look, it's not going to be at 0, 0, because if you look, it's x plus 1 squared, y minus 2 squared. So it's kind of like a circle. You pull out your h and your k, so it's kind of opposite signs. So your center would be -1, +2. So when we're finding our vertices, we're going from this center. So since it's horizontal, it's longer this way, we're going to take the 7 and modify the x value of the center. So I'm going to take 7 and I'm going to add it to -1. And I'm also going to subtract it from -1. So if I add 7, oops, my stylus is coming apart. That's not good. If I add 7 to -1, I get, oh my goodness, no. Oh my gosh. What the? Jesus. This is just annoying today. All right. So if we add 7 to our, so annoying. If I just hit it with my hand, it screws up. It's irritating me. All right. Let's get back. Jesus. There we are. Okay. Let's try not to screw this up this time. So if we add 7 to our center, it's going to be, Jesus Christ. So it would be 6, 2. And if we subtract 7 from our x value, it's going to be -8, 2. So see, we're taking this a value. Okay. Let me pause this. Let me fix my iPad. All right. So I fixed my stylus. I'm sorry about that. But if you notice, how we just got that. I'm sorry, because I'm sure this might be a mess while it's on video. Since our a value was 7, we're adding or subtracting that to our x value here. Since our b is 3, we're going to add or subtract that from our y value, because it's a horizontal ellipse. So our co-vertices, you keep the same x value from the original, but we're going to add 3, so it'd be 5. And then we're going to do the same thing. We're going to subtract 3 from 2, so that would be -1. So we can graph these points. So -1, 2 would be here. That would be my center. 6, 2 would be here. -8, 2. I think 8's all the way. I think these graphs just go up to 8. -1, 5. Or another way you could think about it, like once you plot your center point, ooh, I want 1 too many. What, 2 too many, actually. But another way you could think about it is, like, once you plot your center, if your a value is 7, you go 7 to the right, 7 to the left of the original point. And then if your b value is 3, you go up 3, down 3 from your center. So if oh, dang it, I need to erase that point. So if it's harder to get these points like algebraically, you could just look at it geometrically. You could plot your center, and then you could go up or down, left or right, based on what's your major or minor arc. I'm going to do this last one. I'm going to find the focus points, but I'm going to stop doing that because, quite frankly, we're not going to do a lot with it. But you would take that formula, c squared equals a squared minus b squared. So in this problem, it would be 49 minus 9, which would be the 40. But we want to square root that because we want to get our c. So our square root of 40 is about 6.32. So your focus points, you would add or subtract that from the horizontal values, or your x values. So if you add it to -1, you get about 5. You'd get about 5.322. If you subtract it, you would get -7.322. Okay, but like I said, in terms of like actually getting our graph, it doesn't really matter. But you would see your focus points are roughly around there-ish. Um, really, really rough. I'm just eyeballing it. I didn't even really count, so it could be off. Let's look at a few more. Like I said, I'm going to probably stop doing the focus points because, quite frankly, in terms of getting your graph, they don't mean too much. So looking at this one, our center, you can find right away, is the opposite of what's with the x and the y. It's kind of like when you find the center of a circle. So that's very kind of similar if you know how to find the center of a circle. Since the x is over a bigger number, it's going to be horizontal. So our a squared is 25. Our b squared is 4. So really our a is 5. Our b is 2. So one way, let me kind of show you another way you could do this. You could plot your center. So go to 3, 1. It's kind of hard on my iPad. Since this is horizontal, we're going to use the a value. So we're going to go 5 to the right, 5 to the left. So 5 to the right would be, looks like all the way on the edge of our paper. 5 to the left would be 2 left of the y-axis. Then for your b value, since it's 2, you're going to go up 2 from your center and down 2 from your center. So your ellipse is going to look like, that's so bad, but it would look like that. So you could look at your graph, or you could just, like I said, since it's horizontal, you add to the x value of the center for your a. So you'd have 8, 1, which you can see we did plot, and we would have -2, 1, which you could also see we plotted if you took 3 minus 5. To get your co-vertices, remember you're going to mess with your y values from your center. Oh my god, I hate how I keep hitting that with my palm. It keeps screwing us up. Okay, there we are. So it would be, you're adding to the y value, so you would see you have a point at 3, 3, and you have a point at 3, -1, which I was a little sloppy with when I graphed, actually. It's hard on this iPad to be accurate. And like I said, I'm not going to worry about the focus points because, quite frankly, we're not going to do a lot with them. But like I said, if you are doing a lot with conic sections, you can't. The focus points are pretty important if you're doing different things. But for what we're doing right now, it's not a big deal. So let's just look at a few more examples. I don't know if I'm going to do all of these. I mean, because quite frankly, once you get it, you get it. Like, I mean, they're all pretty similar in what you're doing. But I guess, well, I guess some of these later ones we'll see if they're not in the form, we do have to get them into standard form. So I guess that's a good thing to look at. But 5, your center is going to be -4, -2. Well, first off, is it going to be horizontal or vertical? Well, which are your x's over a bigger number or your y's over a bigger number? In this problem, the y's are. So it would be a vertical asymptote. So our a squared, sorry, what am I writing? A squared would be 36. Our b squared would be 20. So our a is about 6. Our b is going to be decimal because the square root of 20 is about, let's see, what do they put? What is it? It is about 4.47, or roughly 4.5. Let me write this a little bit smaller. I'll get on my graph. Okay, so our center is -4, -2. So since it's vertical, we're going to be adding or subtracting our 6 to the y values. So you would see our vertices are going to be at -4, +4, -4, -8. So if we plot those, be roughly up here. Negative 8, 2, 3, 4, 5, 6, 7, 8, be 2 above the bottom. And then our co-vertices, we're going to take that minor axis and add it to the x values of the center. So if you negative 4 plus 4.47 would be just 0.47, negative 2. And then if you subtract it, you'd have negative 8.47, negative 2. So be roughly about there, and negative 8. I think that's set off the graph. 1, 2, 3, 4, 5, 6, 7, 8. Nope, it'd be a little bit like 1.5 from the edge. But your ellipse would look something like this, and you can see it's a vertical ellipse. It's taller than it is wide. So far we've seen a lot of examples when they give us these equations kind of in standard form, but sometimes they're not going to give it to you in standard form, and that's where you're going to need to complete your square or do some other kind of math to kind of get it in that form, depending on what you're given. For example, this first one we're going to see, I guess it's not, we don't have to complete the square per se, but since we just have coefficients, one thing you could do, because if you look at that formula from above, notice one thing, we always want it to equal 1. Like no matter where your center is, it should always equal 1. So to get this to equal 1, I mean, we could just take 144 and divide every piece by that. Now we can simplify this quite a bit, we're going to see. If you take 9 divided by 144, you're going to get 1 over 16. So we'd really just have x squared over 16. 16 over 144, if you simplify that, you're just going to get 1 over 9. So you're going to see it actually really simplifies quite nicely for this problem. And obviously 144 over 144 is 1. So looking at if our x or y's over a bigger number, our x's, so this is going to be horizontal. So our a squared would be 16. Our b squared would be 9. So really our a is 4. Our b is 3. So and our center is just 0, 0, because there's nothing with our pieces. So since it's horizontal, I'm going to add our a value to the x value. So it'd be 4, 0, negative 4, 0. To get our co-vertices, I'm going to take that b value and add or subtract it from our y values of our center. So it'd be 0, 3, 0, negative 3. And I'll let you guys graph those points, but just plot your center, plot those vertices, co-vertices. You're going to see it's almost going to look like a circle, but it's going to be a little bit wider than it is tall. Let's look at another one where it's not in standard form. So if you see a problem where you got like x squareds, x's, y squareds, and regular y's, that's where you're going to have to complete the square. So looking at 7, the first thing I like to do is just kind of group things up kind of together. So I would probably just rewrite this with the x parts pieced together. I'm even going to leave a little bit of space because I'm going to complete the square. Plus 4y squared equals negative 9. So to complete the square, remember you do negative b over 2, or sorry, b over 2 squared. You know, it doesn't matter really with the signs though. So it would be negative 10 over 2 is negative 5. Squared would be 25. So I'm going to add a 25 in here. But if I do that on this side, the equal sign, I have to do it to the other. So I have x squared minus 10x plus 25. If you factor that, that would just be x minus 5 squared plus 4y squared equals negative 9 plus 25 is 16. Remember, if it's in standard form, we want it to equal 1, so we got to divide this 16 over to everything. So that x part's just going to stay the same. We're going to have x minus 5 squared over 16. 4 over 16 just reduces to 1/4, so we'd have 1y squared over 4. And obviously 16 over 16 is just 1. So your center would be 5, 0. Since I'm running a little bit out of space, I guess I can fit it here. Since our bigger value is 16, our a would be really 4 when you square root it. Our b would be 2. And since our x value is over the bigger number, this is once again going to be a horizontal one. So we're going to add 4 and subtract 4 from the x value. So that would be, if you add it, it would be 9, 0. If you subtract it, it would be 1, 0. And your co-vertices, you're going to add and subtract the 2 from your center. So that would be 5, 2, 5, negative 2. Okay, and you could plot that and you'd see you have a horizontal asymptote. Let's look at the last one. So this one you can notice you got a lot of stuff. So the first thing I would just kind of do is kind of put your x parts together. Ooh, and this one we got a coefficient. Let's kind of, this one's a good one. And we're going to put the y part together. I'm going to even subtract the 76 over, so it would equal negative 76. I'm going to look at their key, see what they do. Okay, that's what I was thinking. Remember, when you complete the square, you don't want a coefficient with your x part, like your x squared part. So the first thing you really got to do is pull, you can pull out a GCF of 4. This pen is not writing well. So you really have 4 times x squared minus 8x. And now we can complete that square. So I'm going to, so negative 8 divided by 2 is 4, so that would really be 16. And we got to complete the square for this y part. So half of 8 is 4. So once again, you're going to have another 16. I'm running out of space, equals negative 76. But remember, we just added a couple 16s. But be careful. Remember, when you pull up this 4, that's really 4 times 16. So we really got to do 4 times 16. That's 64. So we really got to add 64 to the other side. I'm running out of space, but this would be 4. And then it would be x minus 4 squared plus the y part would just be y plus 4 squared. If you add up negative 76 plus 16 plus 64, that's going to be 4. And then if you divide the 4 over, I'm running out of space. I don't know where to write this. Yeah, I'm just going to write it over the graph. I'm sorry. This would just be x minus 4 squared, because the 4's cancel. The y part is just going to stay over 4. And then it's going to equal 1. So my center is just going to be 4, negative 4. My a values, you're going to see, since the y part's over 4, the x part's really over 1. This is going to be a vertical ellipse. So my vertices, I'm going to add my a value, which would be 2, to my y values. So it would be 4, negative 2, and it would be 4, negative 6. And then we're going to add our b value, which would be 1, because the square root of 1 is 1. So we would add and subtract that from our center. So we would have 5, negative 4. And we would have 5, negative 5. So I know that one was a little bit sloppy, but that's what you should get. Did I mess up? I'm checking the key. They got 5, negative 4. Oh, when you, wait, I messed up this last part. When you add your b value, which is 1, or subtract 1, well, if you add 1, you're going to get negative 3. That's what I did. I don't know what I did. This should have been negative 3. If you add 1, you should get, or sorry, if you subtract 1, then you should get negative 5. So I think I just did my mental math there wrong. So sorry if anyone was looking at it like, what the hell? That is the correct answer. So let me double check.